It's great to be back at NOFNEC. This is my fourth or fifth NOFNEC conference, and I was lucky this year. I got a room on the right side of the hotel, and that was the view from my balcony. So I drew a lucky straw this year. And congratulations, by the way, to those in the green shirts who've organized this conference. It's always very good. This year is excellent also, and I'm already looking forward to next year. You've done a wonderful job. There are two things. Yes, indeed. I didn't think I would be alone in my congratulation, I must admit. There are two things I'd like to do this afternoon in the hour and I think a quarter or maybe an hour and a half that we have. I want to talk a little bit with some slides about climate change, partly stimulated by what you can see out of the window. We could all go outside and talk over the first couple of slides, actually. But then to get you working with the worksheets that Kat and Emily and Chantal have distributed to your tables. If anybody's short of a worksheet, you'll get a chance to stick up your hand in about 20 minutes, and Kat and Emily or Chantal will bring you one. And really, it's working with the worksheets that will be, I hope, the greatest benefit for you when you go back to your communities. Lindsay mentioned that we're at the beginning of a 2-year project looking at climate change impacts on communities in the north, and these worksheets simulate very closely the way that we think will be most effective to work with community members. I mentioned that you could see something of climate change if you went out of the back door here, or the side door, and looked up at the sky. You would be able to look up at the evidence for one of the most important climate change gas, the most important greenhouse gas. And it's not carbon dioxide, it's water vapor. And you would see high in the sky, you would see the evidence for water vapor up to between 10 and 20 and sometimes even more kilometers. If you're in a plane like I was flying across the Atlantic last week, you would have been able to see the presence of water vapor in various forms in the atmosphere. Right down low, the water vapor forms clouds, which in fact help keep the Earth cool because they reflect energy. They're like mirrors in the atmosphere. And that's what those lower clouds do. And the average water molecule stays in the atmosphere about 9 days, maybe 10 days. And part of what happens is it evaporates from surfaces like the ocean that you see there, forms into those white clouds which reflect energy from the sun, keep the Earth cool, and those clouds rain, and the water comes back to the ground again. But not all water vapor in the atmosphere is that low, and not all of it returns to the surface that quickly. If you look high in this photograph, right up to the blue sky at the top, it's not quite dark enough for you to see it really clearly. You will see the wispy presence, the wispy clouds, the sort of gray wash of the water vapor in the higher part of the atmosphere. If you go out the back door, what you'll see is the wispy clouds that are way 15 kilometers up in the atmosphere, far beyond the clouds that rained on us yesterday. Carbon dioxide is the troublemaker, and you can think of carbon dioxide as a troublemaker gas. What carbon dioxide does, which we're in control of, not totally, but in a great deal in control of, what carbon dioxide does, it warms up the atmosphere, and it increases the quantity, but more importantly, it increases the temperature high in the atmosphere that enables water vapor to act like a greenhouse gas. We focus all of our discussion on reducing carbon dioxide, and that's as we should, because it's the trigger gas. But the gas that really does the damage is in fact water vapor. And that's the end of my little bit of climate change science. But I would like you to go away with that little factoid in your head and use that as perhaps stimulation for poking around on the internet and learning a little more about climate change science. For those who become involved in our project, and I'll speak about the description of the project in a few minutes, that would be part of the training, if you like, the education program that climate change specialists, as we're calling them, as well as climate change leaders in the tribal councils, the specialists in the communities, would become engaged with. Not just climate change science, but that's a little bit of it. Staying with water and shifting back to the planet, to the surface of the planet, Xavier Saguch in the back there from Yabmatung will recognize this picture from 2009. It's water again, but it's water in Yabamut Lake, and there's a fellow there cutting a hole in the ice. And why is he cutting the hole in the ice? Well, he's cutting the hole in the ice because Xavier's snowmobile had gone through 4 days earlier, and Xavier fortunately had got out. But this is a very good illustration of one of the impacts of climate change. Thinner ice at a time of the year in December when elders and those who know the land well would have expected to be able to snowmobile across Yabamut Lake. But the ice was thinner than it had been in the past. And that costs people lives. I'll bet if we went around table to table here, we would come up with a list of several names of people that you knew who went through the ice and died because of climate change, because of an impact of climate change. Thinner ice at a time of the year when traditionally people would have expected to be able to travel. And this was not in a remote part of Yabamut Lake where Xavier was trying his luck. This was pretty close to the shore, where you would have expected the ice at this time in December to be thick enough for travel. And as I say, fortunately, Xavier survived and his snowmobile came out of the lake. And does it still run, Xavier? Doesn't run anymore. Well, that's too bad, but at least we got Xavier back. Sticking with Fort Hope and looking across actually to the new community, which is up here on almost on the horizon, looking from over where the old community was at the beginning of the last century. People in Fort Hope, as those of you who know the community well, realize, travel across Yabamut Lake, which is what we're looking at, to the Albany River. And they travel across through the Narrows. And here are the Narrows. And that's the way that people from the community travel in the winter when it's frozen, but also in the summer when the water is flowing, travel to the Albany River. And it's the Albany River that's at the top of the photograph there, and Yabamut Lake, which is underneath me as I took this picture. Looks great. But that's what it looks like when you get down close. That is not an easy travel route. That is not an easy travel route. Look at the riffles in the water at the bottom end of the picture there. And imagine that you're driving as fast as the person in that boat was. Getting through here, is getting tougher and tougher. And it's not just because of climate change. And there's a lesson in here that climate change that's causing evaporation and causing increased evaporation in the summer, because summer temperatures are warmer, and therefore lowering the level of the lake and making travel routes more dangerous because water level is dropping. But also the land is rising because of what we call glacial rebound. This was an area, like the rest of northern Ontario, that was covered by a kilometre or a kilometre and a half of ice until just 8,000 or 9,000 years ago. When that ice melted, it was just like taking the load off a ship, the cargo off a ship. Just like the ship rises when you take the cargo off, then so the land rises when the ice melts. And that happens because down about 80 kilometers, the Earth is sufficiently mobile that semi-molten rock moves, and Halifax is sinking because northern Ontario is rising. So if you've got relatives in Halifax, you owe them an apology. So since Xavier was a young boy, the land under the Narrows here, the land under Fort Hope, has risen by about that much. It's not insignificant, it is significant. So if you look at the rocks that make travel difficult in the Narrows there, they're partly exposed because water levels have dropped, but they're partly exposed because the land is rising. And the lesson about climate change is that climate change does not act alone. Climate change always works with something else and usually makes the situation more complicated. So if it was just glacial rebound that was taking place here, travel would be much easier. But it isn't. It's glacial rebound plus climate change. So whatever issue you're looking at in a community, you need to be saying to yourself, how does climate change play into that? And I'm going to show you another couple of examples of this too. So where this sort of work needs to go is how does a community adapt to the issues that it's facing. In the case of Xavier going through the ice on December the 6th, I always remember the date because it was my dad's birthday, on December the 6th, the way to make sure that doesn't happen again is to increase communication within the community so that people know that it's no longer, you can't any longer take it for granted that you can travel on your snowmobile at that time of year. And it needs to be, maybe it uses social media. Maybe that's the way to make sure that the kids, for example, know that it isn't safe to try to go to somewhere or to go to somewhere else this week because the ice is too thin. We need to be using the new means of communication, but also the traditional means of communication, the radio station, for example, and then notice in the band office, et cetera, et cetera, et cetera. But there needs to be somebody in the community who is tasked with making sure that information is passed on. And in this case, it probably means that there needs to be some dredging. Now, I don't mean to get a big dredge out, but some way of increasing the safety of that, of the Narrows there. Staying with Fort Hope, staying with Yabmatung, there are also advantages to climate change, and some of you I know are in communities where you've already begun to take advantage of that. The longer growing season, the shortened winter, the beginning of temperatures earlier in the spring, when you can begin to plant seeds, as well as a longer growing season at the other end. This is one of Fort Hope's ways of adapting to climate change, increasing its capacity to grow vegetables in the community. That land was cleared just this summer. There are challenges, and you can see some of those challenges. One of the challenges is that the ground is not great. That's old lake bottom silt and clay. Remember, the land is rising, so probably about 1,500, maybe 2,000 years ago, that land that now is being cleared for farming was beneath the reserve lake, which is the lake to the side there, to the top of the screen. So it's not got much in the way of nutrients in it that plants need in order to grow well. So part of what Fort Hope's got to do is to get some compost, to get some brown peat, or to get some organic matter mixed in with that soil. So adapting to the potential to grow vegetables doesn't just take clearing the ground, it needs preparing the ground, and it needs It's going to need water, it's going to need irrigation, because part of what's happening with climate change is that dry periods in the summer are getting longer, and the wet periods, the rainstorms, are getting more intense. So the pattern of the summer is changing, and we've heard that from elders in several communities. So some way of getting water from Reserve Lake, which is close by, to that agricultural land is important. And I need to keep an eye on the time here, because the most important thing here is that you get to do some work. Moving to Fort 7. And I want to point out some challenges of climate change by using real situations. I don't want to invent situations. So I want to use Fort 7. And I'm going to go to the screen here. I'm going to point out the parts that are important for this story. So this is the old school at Fort 7. It's the one that had to be demolished because of a diesel leak underneath it. There was, I understand, a pipe that leaked for more than a year before people realized, but it contaminated the ground sufficiently that the school had to be, and not just the ground, but obviously the fumes infiltrated into the building, et cetera, et cetera, et cetera. And the new school has just been opened just a month ago. The questions that need to be thought about that relate to climate change have to do with two creeks, two ditches. This, looking at the north here, is where there are wetlands, and they go further north, way up to the airport. There's a whole lot of wetland that is slowly draining toward the community. And it reaches the community up here, and then there are two forks. This, I believe, there was a culvert under that. And this creek was fed from the north. And you see it's full of water, but it isn't here. This is where it needs to go in order for the water to be discharged to the Southern River. Why didn't it reach there? Because this culvert was blocked. It was blocked with debris. Highly likely blocked with debris. I wasn't there in 2005, but I'm going to show you a picture of this. The other one is right through here. And you can see there's much less water in it, but it is continuous, and it is reaching the river. I want you to bear in mind those two streams as being the way that the water from the wetland makes its way through Fort 7. In March of 2012, March the 21st, the first day of spring of 2012, when the ground was still frozen, thoroughly frozen in Fort 7, there was a rainstorm. And as a result, that creek that had lots of water in it with a blocked culvert looked like this. And I'm standing on where the culvert was, and it was blocked. Right here. So I'm looking north. This is the water treatment plant. And the wetlands from which the water is draining are up here, and the water is coming through this way. And the other creek is running off the left-hand side of the screen. That's a climate change event. Ground still frozen, very heavy rainstorm in the later part of the spring, and also rapid snowmelt. The temperature there was about plus 12 that day. Rapidly increased, so there was a significant snowmelt. But the water couldn't escape because the culvert was blocked. And there we go, and that's what it looked like. There were puddles on the ground. And they weren't just puddles like this, but I've shown you this slide before, and actually it's become quite popular on the internet, I believe. But there were kids actually kayaking in puddles in the middle of the community. That gives you an idea, a very graphic idea, of just how much water was lying on the surface and not draining away. Nothing was infiltrating into the soil. Fort 7 was like a parking lot. It was like an asphalt surface parking lot. That's how the water flowed. Enormously important under those circumstances, and if you're facing an increase in those sorts of circumstances, enormously important to make sure that your drainage is good. So, whoops, goodness. What's happened to that ditch? That big ditch that was carrying the water away in 2012, it's been filled in. It's been filled in to make a ballpark for the school. So that ditch is no longer available. At least it wasn't when I was there in August. And there you can see the water treatment plant, but what you're looking at there is puddled water on the surface. Where's all that water going to have to go? It's going to have to go down the other drainage channel. There it is. And there's the other drainage channel. That's what it looked like in August. And that's the size of the culvert that needs to be able to carry the water from north of Fort Severn through to the river. That culvert isn't going to carry much water. It could easily be blocked. And I don't want to say here, publicly on something that's being recorded, that the engineers have got it wrong. Maybe they've done something since we left in the middle of August in order to make this drainage channel larger. But it's really, really, really important that the frozen surface, rainstorm in late winter, quick melt, be used in a calculation of the volume of water that needs to be able to get through the community. And let me just, I'm going to go backwards here for just a second, and just drive home this point a little more. If this street, which is the one that I just showed you, photographs of the straight street for the public is right here, if that becomes blocked, what happens? What happens? This water floods over the road. It joins the water that's fallen on the road, which is frozen like a crack in mud, and flooding occurs down here. Those are the sorts of discussions, and I want to use this as an example of a kind of discussion that needs to take place as communities look ahead to what the impacts might be of climate change events. It's not just warming, it's surface drainage, it's how well your ditches work, it's the sizing of your ditches, etc. We don't want to get into more climate change science, but I do want to point out one other point that is very, very important in the north, and that is you lie, right on the boundary between two of the most important air masses of the planet, the so-called polar air mass, the colored blue here, and the mid-latitude air mass. And that boundary is what we call the jet stream, northern jet stream, and it's becoming more convoluted over time. And it may be moving north, which means that places like Fort Severn, on that March day, were actually bathed in air that had come from the Gulf of Mexico. At the same time as Oregon and parts of the United States were being bathed in polar air, because this boundary was enormously convoluted at the time. Those are the sorts of pieces of the science of climate change that need to be understood when one's looking at local impacts. I want to come back to Fort Hope again, and Xavier's familiar with this. In fact, I think Xavier sketched this after talking to elders, and this is another practical application, but this time, practical application of using traditional knowledge, of using community knowledge. All the areas sketched in blue here were flooded. Initially, we heard in 1950, we finally managed to pin it down to 1959 because it occurred the year before one of the people Xavier talked to went to residential school. So we pinned it down to 1959. We didn't know what time of year it was. We couldn't get that. But the extent of the flooding was severe. And for those of you who know Andy Yesno's wife, Christine, is it? I think Christine. Anyway, She lived in one of these houses right here and was flooded out, and she remembers that. And you can in fact go to the footprints of those houses, and you can still find some of them. And there was a piece of the front of somebody's stove that was there as well. And you can see the ground and the houses that were flooded. This is part of the community that was expanded in 1992 onto land that was flooded in 1959. Since then, as I just mentioned, glacial rebound has raised the land. So the vulnerability of this part of the community has been decreased. It's been decreased because the land has risen. So floodwater would have to rise even higher than it did in 1959 in order to flood this land. But what we have found out is that it was a climate change event that caused that flood. The records of temperature in, was it Pickle Lake, Chantal? Sioux Lookout. Sioux Lookout. If you look at the May temperatures in Sioux Lookout, the average temperature in May was very low. It was 4 degrees. But on May the 26th, it was 23 degrees. In other words, it was a very rapid late May snowmelt. Meltwater running into the Albany River as well as into Yubamet Lake. And furthermore, when you look at was it again the Sioux Lookout or was it Pickle Lake? It might have been Sioux Lookout or Pickle Lake. Anyway, when you look at the rainfall records in the later part of May for I think it's Pickle Lake, you find that there was a severe rainstorm. It was not a record rainstorm, but that rainstorm was not exceeded, that 1959 rainstorm was not exceeded by 2012. In other words, it was at least 1 in a 50-year storm. Those are the sorts of coming together of conditions, including probably frozen ground still in May because the average temperature was so low, that resulted in the flooding of the Albany River and in the flooding that came from Yubamet Lake. The Albany River and Yubamet Lake are so connected. If the Albany is high, water flows into the Yubamet Lake, and if Yubamet Lake is high, it flows out into the Albany. Both were probably high at that time and resulted in the flooding of the community. So it was a natural event. So in any expansion that Fort Hope, Yubametong, wants to look at in the future, that climate change event needs to be considered. Clearly, we heard a lot about the transmission line and just going out to talk to John and talk to the engineers involved in it. Two of the issues are what to do about wildfires and ice storms. Those are issues that climate change issues that will be part of the discussion of how best to build that line. Now then, I just want to wrap up quite quickly here because we're going to run short, really short on time. It's important to realize that you live in a very special part of the planet so far as climate change is concerned. The red area here right over Hudson Bay is an indication that of all of the land on the planet, of all of the surface of the planet, Hudson Bay and the surrounds of Hudson Bay will change the most between now and 2050, over the next generation. The ice season on Hudson Bay is changing. The water temperature at the end of the summer in Hudson Bay is now about 11 or 12 degrees, which means that it stays unfrozen for a long period into the fall, which provides moisture for increased snowfall in northern Ontario. In your package, which I'll refer to in more detail in a moment, you'll find some projections for temperatures in the north. I'll leave you to look at those because they're in there. Whoops. Now then, to introduce you to the pieces of paper in the handout, and as I do this, you could look at your own. First of all, there's this description of the project that Lindsay referred to as being involved in, which can, if your communities and your tribal council are willing, can involve all of the communities of the North. And I'll leave you to look through it and to read it. Those projections are on the back page. What you've also got is a bit of a sort of a checklist that I've put together called Preparing for the Weather of the Future. And it's a checklist of the kind of impacts, and on the back page, the kinds of ways that a community might adapt. So it's a bit of a sort of a, you don't want to say a cheat sheet, that's not the right word for it, because thinking about climate change is not an exam, but it is a list of challenges, of climate change challenges that are worth bearing in mind. The next 2 pages, double-sided that you've got, entitled Questions for Interviewing First Nation Elders and Community Members, are questions that start the ball rolling when a community wants to put its climate change story together and its climate change vision, its thoughts about the impacts of the future. One cannot begin to think of the future without looking at the past and understanding the story of the past. And it's elders and community members who are in a unique position to provide that. We've tried various formats for this questionnaire. What we've now done is to pull it down to just 4 main questions that allow elders who are storytellers to start to tell their story. So how has the land changed during your life? And then on the back, what changes have you seen in life on the land? So the bullet points underneath those main questions, and there is another page of a couple more, as you'll see, the bullet points under those questions are sort of sub-questions. So if you were the climate change specialist in your community and you were interviewing elders, 10 or 15 of them, and you were doing that with a voice recorder, as the way that we hope will be the usual way, then what you would have to do is listen to the story that the elder told you and to tick off those points like changes in lakes and rivers and creeks, and tick off those as they came up in the telling of the story. And if they don't come up, then you need to ask a specific question. So the climate change specialists who are interviewing the elders will need to be trained to actually do that, because they don't just ask questions, they've got to listen. And they've got to hear whether the parts, the components of the question are being answered. And then the sheets that I'd like you to work with, the climate change impacts, risk, and priorities spreadsheet here. What one would do with the memories of the elders about changes in weather, about flooding, about storms, about changes in the migration pattern of geese, or the timing at which swallows arrive back in the community, or all of those sorts of observations, you would put down on the left-hand side of the sheet, under the area that's, under the column that's called community observations. So the left-hand side of the sheet. And then you would work across all of the other columns, and the only one that I'd like you to look at is in fact that which has got the little graphic on the top that looks like a calculator. In other words, the temperature and precipitation scenario. And to do that, you need to go to the next page, which are the colored pages, which are projections of temperature and precipitation. And I know they look, impenetrable and hard to use, but you'll find that if you glue your eyes on these, you've got an outline of Ontario, you'll be able to find which of the colored boxes your community sits in. And what that will tell you is what increase in temperature is expected by 2050. So that's the way to use them. So this is bringing science into the spreadsheet where you've already recorded the community observations. And then remembering that this is all a bit of a mouthful and a bit of a lot to do, and all I want you to do is really to be familiar with the process. I've given you a spreadsheet here that we've put some time on that's for an ABC community. This is not for any specific community, but it's an example of what a spreadsheet might look like for a community. So what we'd like you to do is to work as a table to discuss amongst yourselves what impacts, what consequences of climate change you have seen or you would expect to hear from elders had happened in your community. Now, there may be more than one community people sitting at a table, and you, in fact, could talk about two communities and run through what you think would be the community observations that you'd fill in on the left-hand side. And then maybe 15 minutes before the end of our session, what we would like people at a table to do is somebody to say, at our table, we spent a lot of time talking about river flooding, or we spent a lot of time talking about the change in the arrival time of the geese and the difficulty that people have in feeding their families because they can't stock up their freezers anymore, or as well as they used to. So what we would like you to do is focus on the community observations, have a go at the temperature and precipitation changes if you've got time, and take this back with you and look at it and think about it again, and read the description of the project that we're involved in. And I'm happy to converse with people in any way, email or face-to-face or whatever you like, about involving your community in a study of this kind. So Kat and I and Chantal and also the green shirts of the organizing committee, I think are fairly spread amongst the tables, and I will certainly circulate and contribute to you figuring out a little more what you're up to. We've got about 15 minutes before the next presentation. And you might want to take 2 or 3 minutes to run quickly to the washroom and so forth before that presentation. So what I'd like to do now, hoping that those conversations at the table have actually been useful and you've made your way through some of these sheets, is to have some people at the tables tell us what have emerged as the main impacts, the main consequences of climate change that you've observed in communities and you think you'd hear about if you talk to elders in your communities. So in other words, what you're putting down the left-hand side of the spreadsheet, which really are sort of the chapters of the community's climate change history, if you like. So is somebody ready to go first? Kat? Or Vern, or somebody at Vern's table. Vern's going to do it. So yeah, why don't you come up and use the mic?
Good afternoon. My name is Vern Chichu from the Mushkegowuk Tribal Council. Some of the things that we talked about at our table was in our regions is the type of weather that we're seeing in our regions, like that we hadn't seen in years, is the thunder that we get in the winter now, thunderstorms, and further to the our region in the James Bay area is the floods. There's a lot more flooding that's happening within our region, and communities get evacuated. The other one is tornadoes, and some of the things that we've seen in terms of changes in the land. Lakes and life is in our region as the polar bears are moving south in the James Bay region. They were talking about winter road, the length of time that winter roads are there is reduced, melting early in the spring. In our region again, there's no geese in the fall. And one of the stories that one of our members at our table told was that the elders in the 70s were laughed at when they talked about the change in weather patterns, and they said that one day we're going to be like Macdelia. We're going to look like them one day down the road, they said, because it's changing. So one of the ideas we thought we'd share is that in our regions, we're going to start building resorts, because people are going to start coming up this way. That's our presentation.
Thank you, Vern. Good for you. I think that the flooding that you're referring to is probably ice jam river flooding. Is that right? Like the flooding that affects Kasheshewan, for example. Yeah. So there's also on the James Bay coast is an increase in storm surge flooding. In other words, flooding of the coastal areas because of storm surges coming in from the winds on James Bay. That's also an issue. Yeah. Speaking of, I won't speak of Kasheshewan actually, but anyway. Anybody else? Great. Could you come up to the mic as well? Thanks very much, Vern. Pardon? Kat, could you make the font bigger? Great. Can you read that, Kat? Chantal? Excellent. Thanks. And Vincent will introduce himself too.
Hi. Thank you. I'm from Bearskin Lake. My name is Vince Osberg. I'm the Community Consultation Officer. I work with we're doing land use planning with the MNRF and all that, and I do a lot of important stuff. But anyway, I was working with my crew there at the table, and it's Andrew Preston from Environment Climate in Toronto, Debbie King, Environment Technician, Deneen Brighton, Environmental Scientist, and Brianne Breton, Environmental Project Coordinator from Windigo, and myself. And we're working on this together. And we decided to do a community profile on Bearskin Lake. And I guess some of the community observations that we covered were that the land is rising, like what was said by the elder Waswa, I can't remember his first name, but Xavier Waswa. And the land, and this gentleman, and what's your name? David.
George, I think.
Okay. Oh, George. Okay. So anyway, the land is rising because it appears to some of the people that go into rapids that the water levels seem to be going lower. So there's talk about the water levels dropping when actually it's the land rising, and that's the local rapids called Katajuan. Spawning sites have also. I was wondering. I was thinking maybe the spawning sites are all fished out now because we have two traditional spawning sites that no longer have fish there. And I guess that's also related to the land rising because the fish moved away. And also the lakes, there was one elder who was saying that a lake that used to be safe to cross as he goes trapping in the winter on the Severn River, there's a lake about nearly 20 miles away. He said that lake used to be safe one to cross, but it's no longer safe. It's unpredictable. And he said that at a certain time of year, late February, early March, that he used to cross that lake and you can't do it anymore. And there's also an increase of predators, wolves, wolverines. One hunter a few weeks ago was almost attacked by a wolverine. So, I mean, actually, he was attacked, but he shot him by him. So that's the end of that day, the dispute, you know. So the changes of weather, the snow was unpredictable. Like if you recall last winter, some of you may have been, those of you from the north were probably skidding all over the place, like you're sliding on your roads, and it was very icy, you know, you're either going into the ditch or whatever. A lot of precipitation, a lot of wet snow was found, and it didn't snow much in December either. Like there was no dry powdery snow in December. It was pretty much barren. You had a few flakes, and the snowfalls just came later in January, February in the north, in our region, in Bearskin Lake. And I guess that when we look at where we were, we identified that we looked at the latitude and longitude I forgot to bring the paper up, but the latitude was roughly 91 west and 94 north or something. That's where we're located. So it's on, if you can look it up, where precipitation wise we saw the increase of precipitation, etc. And I guess the changes of what happened is that we have 20% more snow. That's what we're getting now. We're getting, actually, to be more correct, 20% more wet snow. It's not dry powder snow, it's more wet snow. When I talk to a couple of the experienced middle-aged people, the elders, there's a couple of observations with wet snow as opposed to powder snow. Is that, you know, years ago we'd probably get 3-4 feet of powder snow. Now we're getting, you know, a couple feet of wet snow. If you recall, in your area, some of you probably don't have frogs and toads anymore. The reason why, because they're probably all dead. They probably all died because they froze to death. Same with the other hibernating animals. They likely froze to death too because of the wet snow. They're not insulated with the powder snow. So you probably see a lot of less animals up there because of the increase of the wet snow. 20% of that has increased. There's 3.5% more rain in the summer, especially in September. We had a lot of rain in September that normally would happen in October. All this rain came in September. That was reserved for October weather. And that's a change of climate change. And so we see an increase of precipitation of 3.5%. The 4% increase in weather means that the temperature goes up by 4 degrees Celsius in the winter. So we're having warmer winters. We had a 2.6% increase in temperature in the summer. Actually, when I did the calculations, I based it from Silicon to Bearskin Lake. On average, I used to calculate that if it was 20 degrees minus in Silicon, it would be about 30 degrees to 35 in Bearskin, 15 degree difference colder. So what would happen is that because of the increase in temperature, I did a calculation that I used 3%. Actually, it says a 4% increase. So what we have now is that a 3% increase, it goes down to 80% as opposed to 100. What that means is that we lost 20% of our winter road time. Whereas we may have had 8 weeks of winter road season, we now drop down to 2 to 3 weeks. At 80%, it's 2 weeks we lost in our winter road time. Beyond 80, we lost 3 weeks. So that's how much we lost, is 2 to 3 weeks of our winter road time. And that basically sums it up. And it was our team that we put this together. So thank you.
Wow. I think we've got time for one more report. Stephen, you're volunteering? Oh, Natalie, you're being volunteered. Are you going to have a go?
I'll make it quick because we're
Yeah, we do need to be quick.
Maybe we can get one more in. I'll speak, but I was working with Bearskin and Satchko area people as well. And Vince made a lot of very similar points to what we brought up, but I wanted to add to a couple. One that I never would have thought of was a couple of years ago, there were some severe forest fire conditions, and they've seen change in the landscape since then, especially in the absorption of the water in the wetlands, and some of the bog areas have gotten drier. And they seem to think that due to the fire season, there was a lot of regrowth change, new tree growth in bog areas and changing landscape, which has impacted migration or different habitat routes as well. The other one Vince touched on, it was snow conditions. Not only are we talking about different temperatures that we noticed in the winter, lower temperatures, less of a freezing season, late freeze season, but the snow itself has changed. It doesn't get to that crystallized form of snow, the coldest form of snow. It melts before it has a chance to accumulate. So we're getting bigger dumps of snow in the fall, which less chance for the ground to get the deep freeze, and less accumulation of snow, ground cover, making for sloppy land conditions, not able to freeze or able to provide quality winter roads or freezing conditions. So those are a few, but we did get a lot. We talked about spring, winter, fall seasons, and summer, different effects in each one of those seasons.
Thanks, Natalie. I wish we had more time to go through more, and a round of applause for all of you, for all of the conversations at all of the tables. As I say, I wish we had more time, but it would take us a couple of hours to put everybody in front of the mic and gather everything. So thanks very much for your attention and for your participation. Thank you.